Hello. Okay, so in this video I'm going to take apart a water boiler urn, like for dispersing hot water for making cups of coffee and tea and that. I got these items from a mate of mine who was just going to be chucking them out anyway. My latest video that I took apart was the TV, the LED. The latest video regarding taking stuff apart was the LED stroke LCD flat screen TV. So today I'm going to take apart this hot water urn. I've still got two things. I'm going to be taking apart other things, but I got four things from my mate who's going to be chucking them into the dump. It was a TV, the urn, an electronic chessboard, and an old clock as well. So I'll be taking those apart. But today I'm taking apart the urn. So I'll show you this urn first of all before I take it apart. So this is it here. It's basically a Swan hot water urn. That's the specifications. Somehow I'm going to just put the bottom off it and have a look inside and just see what's going on. The other things that'll be dismantling is this old clock. This is going to be getting chucked out as well, so that'll be done in another video. And also this electronic chessboard, that too will be getting done in a separate video. But for now, I'm taking apart the stainless steel water urn boiler, or whatever you want to call it. I've never taken one of those apart before. I take these things apart because for two reasons. Firstly, I'm interested to see what's inside them. I always have been. And secondly, I'll share it with you as well. Make a video of it for anybody else like myself that wants to see what's inside it before it gets chucked into the skip. Because, you know, in the modern day, it's like a throwaway society. Something breaks, just chuck it in the bin and get a new one. Whereas if you go back to the 80s, 70s, I remember this because my dad used to fix lots of things. You would buy something, it would last for years and years, it would go faulty, you'd send it away for repair. But in my case, my dad repaired it because he's an electrician and electrical engineer, as well as fixing other things, cars and all sorts. I used to watch him do all that, do homers and everything, and I was always curious, and it was kind of like hoping something would break so my dad could take it apart so I could see inside it and learn what's inside. So that curiosity's still with me. So that's merely what I'm doing when I get these items. Just to dissect them, take them to pieces, see all the bits, and then just throw it out, rather than just throw it in the bin and that's it, and buy a new one. I like to see what's going on inside. So anyway, I'm going to get this up to the the pasting table, and because I do these videos outside because it's uniformly lit, and when you're opening up items like TV sets, DVDs, cookers and stuff, there's lots of shadow. If you're doing it inside where there's one light source, a light bulb, then you get a lot of shadow and you don't really see very well. But when you're doing it outside, it's much more uniformly lit, so it's good for the video purposes. So that's why I do it outside, and also so I didn't make a mess in the house. So I didn't want to be disturbing others, so I just do it at the back side of the way. Right, let's get this up to the back ace. I'll get the pasting table and the toolbox, and I'll start stripping this boiler down, or water on. It's not like, it's a boiler in a way, but it's not like it boils water for coffee. It's not like a boiler for heating or anything like that. It's a small urn. Okay, let's get on with it. That's where the water comes on with. And the make Swan. And it's just the domestic plug that goes on it. A couple of switches, and that's about it. So let's take it apart. Right, so got the boiler here at the back edge out the way. Hopefully stay dry. Got the toolbox just there. So let's start flipping it apart then. So just as a precaution, got a pair of heavy duty gloves for any sharp edges, anything like that, if I need to pry anything open. I've got a shot of my dad's toolbox, one of his toolboxes anyway. I think the first thing I want to do is sort of have a look at it and examine it first. So basically the water will go in here to the maximum, full line. This will be the dispenser valve, which I'm sure there'll be like a, if I could get a light on and maybe see if we could see that as well. So I'm opening it now, and it seems to be jammed. It's difficult getting it open. It seems to be sealed shut, but there is a locking nut in there that I could maybe get an adjustable spanner onto to get this off. So I'll go and dig a spanner out, and first of all I'm going to take that valve off. So it's impossible to film this and do this at the same time. What I've done is I put the adjustable spanner onto that nut. I just held it there, and with my left hand, while that was being held on the inside, I just unscrewed the tap in order to remove it. So with the locking nut removed, this should in theory just come out, which it does. And get a closer look inside. Maybe be like a butterfly valve or something in there that will open and regulate the water, and it is seized unfortunately, but I don't think I'm able to get the light in there to show you. I'm trying my best to, but I'm just getting much. So there's another nut there I might remove, and that's a seal, a water seal, obviously to prevent the water from getting out. It's seal tight. Seal there. See if we can whip that off. So this pried that off with the help of a flat screwdriver, and this sort of nylon or rubber or whatever it is seal removes. That then gives you the bare stainless steel metal. So that's the components. There's another secondary washer like seal in there as well. I'll see if we can get this nut removed. I removed this nut using the pliers, the adjustable spanners, but it doesn't seem to be doing hee-haw at the moment. Did it with the hammer to try and extract the valve. The valve now opens now. It was jammed, but let's see if we get the light on. Brass, I guess. Similar to that will be used. Is it maybe copper? I don't know. It's similar sort of setup that you use for the like the taps on your sink in your bath and that, I guess. But it's certainly freed off a bit, so I'm going to remove it completely now. Right, so I've got it off. That's the valve body. Now let's see if we can show you that. The water passageway. Unfortunately, it's blooming difficult to get this to focus. It's really annoying actually. You can see it there. I'll try and zoom in. The water passage there, and the other passage, the other end. The water will basically come through here and out of there. This here is the valve, which will screw in. These holes will line up. These holes will line up with those holes, which will allow the water to flow through the tap. When you close the tap and you turn this handle, this metal, you can see the evidence mark there, that there, and there, will block off these holes, which will stop the water from coming out of the tap. So it's just something like this. So it's basically, you're just going to, from my understanding of it, and no plumber by the way, and just making it up as I go along and just figuring it out as I look at it and using my understanding of it. Don't quote me, and just saying what I think, how it works. So when you turn the tap, I can't really do this and film at the same time, but when you do that, that will be opened, the lines, the holes will be lined up, the water will flow through, so water's going to go through because these holes are lined up. When you close the tap to stop the water coming out, you would just turn this, which will cause these holes to go to this, and this blank bit here, and on the opposite side will close off the holes on this housing, and the water won't go any further than this valve because that's going to block it. So that's my understanding of how it works. So like I say, I'm not a plumber, so don't quote me. This is just for entertainment purposes. It's not like quoting this is how it works. This is just how I think it works, just from what I'm figuring out. And as I say, it's only for entertainment purposes only. So it's not for quoting on me. Don't quote me. I'm not a qualified plumber. So, right, I'm going to get this thing taken apart even more for you. So this is what I've done up to now. I'll move them out the road. Next task. These handles are maybe Phillips screwdriver. I'll remove the handles. There's a handle on each side. Phillips screwdriver to take them off. This ought to do it. I'm right-handed by the way, but I'm holding this camera with my right hand, so just showing you as a demo. And then screwdriver required. Yeah, so I was right-handed. I couldn't actually perform the task because I was holding the camera, but basically you just unscrew it. And when you do unscrew it, this pulls off. And that screw's only there to lock onto this bracket. This bracket's brazed or riveted onto the stainless steel container. That's just a mounting bracket for the handle. One Phillips screw, so it just press fits into there basically. And the Phillips screw just locks it in, sits you. So the other one will be the same, I presume. Again, just demonstrating. And that's that enough. So, both handles off, taps off, and both handles, valve tap. Try and keep them in some sort of order, because I'll do a photo slide at the end with all the pieces put in a nice presentable order so I could show all the bits. So we'll put them there at the road for now. These blanket taps, the valves, washers. Tools required: hammer, flat screwdriver, Phillips screwdriver. This is the tools I use by the way, adjustable screwdriver. Next task is going to have a look at the element, I believe. So this is the underside. I'm going to take out 3. Ah no, what the hell is this? That's not Phillips. What's this? I don't know what that is. I don't know how I'm going to get that off. I might have to just joy it with a flat or something, because I don't have a, well, I don't have one at the moment anyway, so I'll just work with what I've got. First thing I'll do is I'll take these 2 Phillips screws out. Then it's quite straightforward, just sliding them off. A little bit deeper than I thought, these screws. What's this reset button? I never knew there was a reset button on it. I don't know why you'd have a reset. Unless maybe when it boils, it switches off the boiler, and then to reboil it you've got to reset it perhaps. It'd be an awful chore because it'd be full of water and you've got to go underneath, so I'm not quite sure. I don't use these things, so I've never really had any dealings with them. So it's as much new to me as it is anybody else who hasn't seen inside them, because I'm learning as I go along here as well. I'm basically just winging it, just making it up as I go along basically. So see if we get a flat one there to get that off, flat screwdriver. So I used a wee flat screwdriver, I just dug with it the toolbox there, and I managed to slacken this off. I don't know what type of screw that is, I don't even know why they're having an odd one out like that. But anyway, it's off, so that's the bottom off. It's the reset button. Ah. So, I'm presuming that's a thermal cutout switch, and I presume that will be also similar to what I've seen inside the microwave. There are thermal cutout switches on the bodywork. These are spade connectors, they just should pull off, which if you pull hard enough they should come off, which they do. And the switch is probably pries these plastic things in there. Should just come out. But they basically pry down. There's one on the bottom, one on the top, and as you press down on that plastic, it should release the switch from the steel body. So I'm going to wait to, well, yeah, I'll put the switch out, and then I'll get this dress base trim off as well. Actually, before I start taking all these wires off, let's just going to have a wee sort of examine this for a minute before I totally take everything off, because these switches, all I need to do to get this stainless steel ring, base rim, ring or whatever the hell you want to call it, off, you just need to take these wires off and this mechanism here. So what's this then? Reboil. Right. See, I haven't used these things, so let's just see what happens. So that's making contact. You can see the mechanism, how it's sort of making contact with this, probably be the element switch in, and then when it heats up, the switch will pop like a thermostat, maybe to cut it off. So your mains voltage comes in, and then it goes to the main switch, which is your on and off. That's obviously lights up. That's the 3 wires that I've pulled off so far. I'm going to keep them in situ just for now, because I want to just have a wee look at this for a minute before I take it totally apart. This, by the way, is an LED that lights up this red light, and there's a similar one at the bottom, but green. Keep warm, keep boil, reboil. Ah, no, that'll be the element there then, or the contact step. So yeah, and just having a look in here, as I say, I've never really had any dealings with these things. I've never worked in like these burger bars, the burger huts and stuff. You would typically see them in there, and if you're asked for a coffee, the guy will just get some hot water out of there and make your coffee, and that's really just a big reservoir of hot water, like a giant kettle basically, industrialised. I've never operated them before, so I'm kind of like just literally winging it how it's working before I understand how it works. But yeah, I'm going to just trace the wiring and sort of figure out how it works, kind of. So, as I say, I'm not a qualified electrician. My dad's busy at the moment. He'd be able to tell you how this works in an instant, because he knows all this. I'm not a qualified electrician, so I'm just kind of like guessing. That's why I'm making it clear, don't quote me, and don't attempt to open anything up that you don't understand with regarding mains voltage. So I'll just emphasise what I said there. If you don't know what you're doing when you're opening up any electrical appliances like that, and you don't know what you're doing, don't do it. Just don't do it. Don't open anything up that you don't understand, because these things could kill you. So if you don't know what you're doing, just don't even attempt to open it. So I've said that, so that's it. I've made my point there. I'm not going to encourage you to do it. That's the best way. You'd never open these things up while this is plugged in, because all this is live. That's 240 volts, and that'll kill you if you get a shock off of that. So you do not open this stuff up when it's plugged in and switched on. Always unplug it. And if you want to be extra sure, take the plug off or take the fuse out. So but that always used to tell me as well, for extra safety, if you're doing work on electrical appliances, take the plug off, take the fuse out, and there's no danger it'll get plugged in by mistake while you're tinkering around inside it with live wires, because that's lethal voltages. Right, so this protective sheath in here, I guess, is just to prevent it from chafing on the sharp metal. There's a grommet there as well, just to keep it protected. So the mains voltage will come to the main switch on the outside, and then from the switch, when you flick it on, it must go to all these, I'm presuming they're thermal switches, and this mechanism here, when you press the reset, or the reboil rather, makes contact with that. So there isn't, I don't see any circuit boards or anything in here. There is a printed circuit board material here on this reset, which does a similar thing to the reboil. See if we could zoom in on there. Now we're getting a bee joining us. Don't want to get stung though. Buzz off. Right, so that bee's flew away. No, where was it? Right. Come on, I'm just going to strip this thing apart, bugger it. Right, I'm just going to start taking all this trim off and get all these components out. You can see the diagram, you can see how this wired up. I'm not 100% sure, but I think they're thermal switches and stuff that'll break the circuit. So when it's up to temperature, that will break the circuit, which will stop the electricity going to the element and stop it from boiling. And I presume when you hit this reboil, it will then reset this circuit breaker or whatever it is, and then the power will go back to the element to reheat the water to the boil. When it reaches the boil, it will then trip the thermal switch, which will cut the power to the element. The water keeps its thermal temperature because it's a good thermal, there's a word for this now, thermal capacitance I think it's called. It keeps its temperature. So yeah, so thermal capacitance means that the water, it's acting like a capacitor that will keep the thermal heat energy within it for a while. That's why water's good for a good medium for radiators and for heating your house, and similarly for cooling things. I mean, like in the winter, for example, the water, the sea and nearer rivers tend to be a little bit milder, so it's not quite as much snow there. And in the summer, it's cooler because it remains colder or cooler compared to the rest of the land, and then you get more sort of fog and stuff coming from it. Something like that anyway. It's generally, the water's milder in the winter when it's colder on the land, and cooler in the summer when it's hotter on the land because of the thermal capacitance of the water. It retains the temperature longer. It needs energy to heat the water. It keeps this heat energy in it longer than air. Air's an insulator as well. So as I say, once the boiler's up to temperature, the water will remain very hot for quite a while, and when it drops below a preset temperature, the thermostat, I don't think there's a thermostat in there, I think you just press the reboil and it just reboils it, and then it'll stay hot for ages because of the thermal capacitance. It stores thermal energy, water, similar to a capacitor on a circuit board. It stores electrical charge. Just wanted to sound clever. Physics was my favourite subject at school. I actually got a higher physics. I wished I went further with it, but that's life. That was many years ago, back in 1992. But I'm a little bit rusty. Anyway, enough of that. Let's get into I just don't want to get hang on a minute. I don't want to start rushing too much. I just want to have another wee think about all this is together. This, by the way, that's your LEDs for your lighting, and they just screw on. I think that's it. Oh yeah, they do. They just screw on with this lock line, plastic, and that should just come up, which it does. Similar to the green one. I'll just be unscrewing. It's a good idea to wear these gloves, by the way, when you're doing this, because all these sharp things in there in case you cut yourself. I brought them anyway, in case it was going to be cutting through the metal or anything, for whatever reason. As I say, I've never had one of these apart before, so just thought I'd make it up as you go along. Now, this reset button, I think it comes past that, doesn't it? So that should just, it's a ball joint, but that rubber. Come on, get out. Good. Get it. Right, there we go, there's a button there. So, this shaft, metal shaft, just goes into the inside of that button. It's not actually physically locked onto it or anything, it's just that plunger bit just goes in there. And this now should just, won't actually lift off yet because of the flex. So I'm going to take the spade connector off here. And there's an earthen one. Is that an earth? That'll be the earth. It must be the earth wire. These things will be earth, so if there's a short circuit, this won't become live, or it shouldn't become live if there's a short circuit. If one of these wires break, they're heavily insulated, they've got this extra insulation on them because this is in a metal case. If one of these wires the insulation was to fail, and a live wire was to touch this case, instead of killing someone that touches it, it will short circuit, causing the current to go right up. Because it's a short circuit, there's less resistance, it's just going straight back into the circuit, it's just coming out the live through whatever the cables touch the casing, and then it's going to short out through the earth wire back into the plug and blow the fuse and blow your trip meter in your meter box in your house. That's the theory, and it does work if you get a short circuit, but you don't want to be touching anything that's got wires that are, you don't want to be touching this. This is just a safety device, this earth wire. If a wire touches that, you don't want to be, this is just so that if it happens to touch it, you hope that this is going to cause the fuse and to blow, basically, because it's going to draw maximum current, too much current. It's just a short circuit. The fuse will melt inside, blow the fuse, break the circuit and stop the power going to it, which should then cut the electricity from this. That's an earth wire. And typically the phone rings. Give us a second. Right, sorry about the interruption. It's my phone ringing. Where was it? Earth wire. Yep. So I believe, as I say, don't quote me. I'm not an electrician. I'm not a qualified electrician, but I believe that's the earth wire because it's going directly to the metal case. And like I said earlier, it's got a locking washer on it as well, just for safe keep, so that wire doesn't come off, because that is a safety thing. That's all the wires. Or is it? Is it? Is all the wires? No, there's a cable tie. So I cut that cable tie, snip that off, and then I'll get this lead out of the boiler. So, a pair of snips required to do that. That's it done. That frees the wires from the. Now this tough grommet, which has got to be tough because it's to stop them, because this lead, you know, this metal's sharp. When did I take that thing off now? Yeah, there. See, that's just the bare metal, that's sharp. So if that cable was just directly making contact with that metal, eventually, just due to wear and tear, it could cut through the insulation, cause a short circuit, potentially making this live, which could potentially kill you. That earth wire's there as a safety measure to blow the fuse in the event of that happening. But you don't want to, you don't want that kind of shit happening. So you just put a grommet here to make sure that it's rubbing against the softer material, so it doesn't cut through the insulation. So that should then free the ring. That's the base ring off. Now, with that out of the way, oh, the switches, by the way, that's, and I didn't get that switch out yet, so maybe this will take this opportunity to get it out. It should just press down. There's a couple of tabs on each end that you squeeze together, and it should, in theory, just come through the case. So a little bit of gentle persuasion perhaps required. Right, you got it. The tab kind of broke on the way out, but it's out now anyway. And I suppose I could do this flex later. Right, now that's the mechanism in a bit more clearer. Like I said earlier, this push reset button just basically just fits. Remember, that's fitted to the ring, so that's held in position, and that end of the shaft just fits in there. So when you press it, you're really effectively just pressing that. Just makes contact with this adjuster or whatever, this rocker. It's got a spring on it as well. That's now released fully because there isn't any resistance, because that's really meant to be there. That's coming past the stop. So when it's in situ, it's unholding up with my hand at the moment, but when that's held together with the ring, that white button is fixed to the ring, which holds this in that situation against the spring. But because I've took the button off, and the whole thing's just come apart, so it's came right over past the stop. But that was originally how it went together. It was like that, and you could see it, how it makes contact. So on this is just a plunger, and it's sort of, basically it's a remote mechanism, and it's hitting this button here, which must be a, I don't think there's no wires. There's an adjuster screw on there as well. There's an adjuster screw, which is something I didn't really think of, because it may need adjustment. It is mechanical, so mechanical things wear, so there is tolerances in play when it comes to mechanical moving parts. So they've allowed for adjustment by having this adjusting screw, and that really is just pressing that button there, and similar to the reset button as well. So a couple of bolts, and I'm going to just whip all that off and see if we could get into this. I don't think this could be the element. It must be encased. It feels like maybe a ceramic or something, I don't know. Heat, kind of just, that can't go red hot. There must be something in there. It's held together. That's certainly the contacts to it, but the element must be integrated with this basin. Integrated. That's a bit of voltages and shit, numbers and things here. 240 volt, 150 watt. That'll be a part number or something on there. Some other numbers written on it in red. I don't know what that is. Maybe a production number or something. Right, I'm going to whip all that off and have a look at these bits in more detail when they're off. Now, I didn't have the time to go and looking for all the proper socket set and tools, and no digging all that out. I don't think my dad knows where they are, they're buried somewhere. So to get these bolts off and doing it the way you really shouldn't, and join it up, because this is just going in the bin anyway. So I'm using a pair of needle nose pliers to slacken off these small bolts, nuts, basically, to save time, because it will do the job. I'll get them off. You wouldn't. That's not how you're meant to do it. You're meant to use the proper sized socket and tools for it. But I don't have time for that. I'm just going to wing it. I'm just going to use these. It gets it off. It gets the job done. As I say, this is just going into the skip when I finished anyway, so it doesn't matter. I'm just going to get it off, whatever means necessary. We're stuck. What you do is, what I'm doing here is just using these pliers and just simply doing it this way. This is the joy job, enjoying it up. It's not how you would do it properly. It's certainly not professionally. I admit that. Like I say, I know being a monkey is, this is going to the bin. I just need to get this off, get this done, get this video edited, and get on with the rest of the things. I've got other things to do. I just don't have the time. It'll take me about an hour and take me ages to go and find the tools. Are stacked away. So I'm just going to simply do it this way and get it off this way. The outcome's the same. These bits will be off, and I could show you them in detail, and I could get to see them in detail. So I'm going to simply do that and get on with it. Actually, before I whip it off, I'm just going to see how it's mounted. There seems to be an overlapping ways. There's a little lock ring and spring there as well, on there, that needs to be removed. So it's well put together and it seems to be sandwiched. There seems to be this mounting plate and the switch below it is sandwiched between that and the bottom of the boiler. And there's these little washers as well that I'm having great difficulty removing at this moment because nails aren't quite getting around them. But you can see this is going over there, that's sitting at this angle, and this is going on like that. Ah, now these are magnetic, and guess what? The screwdriver is also magnetic. This gets these lock rings and the nuts out of the way. So much easier rather than trying to dig them up with the nails. So I could get these washers off a lot easier. So now we've got it off. That must be heat paste or something. Conductive. It's like what they use on heat sinks for microchips and transistors. It's a conductive paste so that it's got to transfer heat off the base. That is I'm beginning to think more of that's the thermal cutout switch. Again, it's spade connectors to get them off. Now it's difficult filming and doing this at the same time, unfortunately. But so my hands are covered in all this muck. It's heat paste, conductive. So these basically this thermal switch, that's a mounting that I get round it there, which will come off. That's the actual the component. That makes contact. This bit that's covered with all the paste makes contact with the base of the boiler. That makes contact with that. You can measure the temperature because that's directly onto the steel bottom. Now that's just the mechanism shaft that's put them at the road for now. But there's another one of these on the reset button side, so we'll get that taken off as well. So just about there. And that's that's what printed circuit boards are made of, like for mica or toughnum or something. And there's a spring loaded. Oh, actually, just see what's going on here. There's a spring around there, but oh yeah, that's that bit there. It's the washer. It's compressed on it, and then the component. So this is a longer kind of nut that has to come off. Another thing, what I might mention as well, is because this carries lots of water in it, it's the water, the impurities in the water that conducts electricity. So these spade connectors also have all got to be kind of heavily insulated in the event of a leak. And again, the earth wire should allow the fuse to blow, because if it shorts out due to a leak, then it should blow the fuse and blow the trip switch in your meter box in your house, or on the burger van's fuse box, or wherever this is. Because if it's going to be plugged into mains, it's going to be likely that there'll be a fuse box as well wherever this will be used. So it'll blow the fuse and trip the meter as well, trip the switch at the meter box. So these are slightly longer to get this out. I'm going to have to get these slackened off. Come off quite. There's actually a nut underneath there as well. Looks like it raised or elevated. I'm not quite sure exactly what these are called, but they're pillared. Thread on the inside, a thread on the top, and then you've got spade connector, and then other two small nuts there to be slackened to remove this thermal switch from the base of the tank or the boiler. Although I've got these nuts slackened, it's proven to be an absolute nightmare to get them off, because It's seemingly this flat is hitting against the side of the thermal switch, and it's stopping it from slackening any further. It's the corner of the hexagon bit there. When it turns, it's banging into here, stopping it from turning any more. It's a bit of it's awkward, so it's proving to be a bit of a pain getting them out. Really am having difficulty getting this one out for some annoying reason. It really is stubborn. So I'm beginning to wonder if I'm going to get it out at all, period. I mean, it's not a case I could just yank it out with a flat screwdriver because it's literally bolted in there, and that bolt ain't turning anywhere. It's just blocking me out against this. I don't have any tools to drill it out neither. Well, not a hand to do it anyway, and I don't have time to go searching for them. It's really annoying, that. I don't know how I'm going to get that out. It's so close to coming out. It's so close. But it's slack, but it just ain't moving any further. Same with the other nut. It's so annoying, right? So annoying, like, really is so annoying. I don't know. So blood, sweat and tears to get that off. But I got it off. There's actually some specification writing on the bottom as well. Again, it makes contact with the base, but it seems to be making contact with this bit, not the actual base where the water sits on. There's this other skin as well. So I don't know why. I mean, I don't know if it made much difference, but that's the corresponding one. That's the reset one. The tools that I used to get it off was just hammer, flat screwdriver and snips, and I just used the metal fatigue to basically flex it back and forward. The metal will eventually fatigue it where it's been flexed it, then it will just part company and it will come off. So I've done all that and got it off, because these bolts now, which will come off now because the component's out of the way, but the component was preventing these nuts rather from coming off. Although this still doesn't want to come off, it meets the top of the head, but it's probably because the thread's damaged. But I don't really care, I've got the component off now. I wanted to see the underside of it and what was under it, so that's all that matters to me now. Next thing I'll do is I've got another one, but this should be easier. It should just be a case of the 2 Phillips screws, and it should just simply come off nice and easy. Now this, I don't know if this is another thermal cut off or why that one's there. Is it an overboil? If it makes sure it switches off when it boils or something. You've got reset, you've got reboil. That might actually be the automatic one. Again, it's got the heat conductive paste, and it makes contact with this bit of the boiler as well. So I'm guessing then this assembly will be the element assembly. It looks like it's kind of like I don't know if you could replace them then, because how do you replace the element on one of these, if indeed you could? Is it a serviceable part? I don't know. So that's obviously the wires to the element, which I could remove. Phillips screwdriver. It's not so easy doing this and filming at the same time. We need to get the thing going. That's why you. It's not worth it. It's only just for demonstration, really. I'm just getting that initial. Once it cracks loose, once you get that initial turn, then it's plain sailing normally after that. A couple of other Phillips screws to come off. So that's the wiring harnessed, removed from the bottom of the boiler. Not really much left, just basically the tank itself, stainless steel of course. Something similar to that is what's used inside a washing machine drum, tumble dryer, kettle, stainless steel kettle. So the element itself is, this is the business end, that's what does all the heating. This is the main component. I'll get these legs at the road as well. I'm just getting in the way. These sharp corners are just basically waiting, an accident waiting to happen for me to catch my hand on them and cut myself, because they are sharp. As usual, I've got my gloves, never wear them but and these are quite self-explanatory. Just unscrew off, lock a nut and washer. So that's the legs off. There's this couple of bolts to get that off, but I'm not going to waste my time taking that off. There's not really much point in taking that off. There's nothing really much to see. These elements, I begin to doubt seriously that is a serviceable part. To me that looks like it's welded in or bonded to the actual base. It looks like it's actually, there's no way that's coming off without like having to get an angle grinder and cutting it off. I don't see, in my view anyway, I don't understand how that would come off. I bet it doesn't. I bet that isn't a non-serviceable part. So if that basically goes, if that element goes, this whole boiler, or urn rather, I keep calling it a boiler, but it's, technically it's in Swan hot water urn. So this whole thing will be scrap if this element goes, because to me it looks like it's a non-serviceable part. I don't know how you would get that off. It looks as though it's completely bonded into the base of the... I don't see how it could come off. So if your element goes, that's it. It's a new one. To get a complete new urn. It's just the handle off the lid. It's like that of a pot lid. Probably a Bakelite handle or something, is it? Just maybe a heat insulator. Again, just press fit. A couple of locking tabs there and there. That just fits it in. Phillips screw on the underside and that holds it in place so you can lift off the lid, and that's all there is regarding the handle of the lid. Now, these legs are called legs. They aren't actually legs. That was my mistake. These are mounting posts for the base of the urn. So that's what they were. They fitted onto the base of the tank, which holds, it's fitted on at one end, and at the other end is a hole for the screw to go through the bottom of the base of the boiler. So that's just basically what they are. It's not actually legs. The boiler sits on this. This is the legs, if you like. This is what it sits on. There's not really much point in taking I'm going to wrestle getting this flex off of there. There isn't really anything. I don't gain anything. I don't see anything by doing that. It's just grommet fit. So I think that's it, really. That's it. I mean, you could probably break open the switch, I suppose, and see the contacts inside, perhaps. Yeah, I might do that. I'll go and do that now. Fortunately, due to the methods used in opening up the switch, it kind of exploded into bits. So I've achieved as much as I could. This is the inside of the switch. I'm guessing there's like an LED or something. You might just see it there, tucked in there. And that will light up this red casing when power is applied. And there's a spring that came flying it. And another wee spring in there as well. There's the contacts at the bottom. So I don't know what other wee bits came out. I put a screwdriver to the side prior to home, and as this button came out, it kind of popped out and all the bits came out as it was I put the hammer through the side with the screwdriver. It was the only way. This is a non-serviceable thing. If this switch is no longer operating, if it breaks, it's non-serviceable to my knowledge, because it looks like it's a sealed unit. So the only way of getting is to burst into it, and of course I think what they do is they mould it, the components, they mould this plastic on the components or something, because it doesn't look like there was any seams or anything in order to get the switch apart. It was just a case of having to hammer and screwdriver through the side and kind of brute force, and then doing so the thing just came to pieces. Spring came out. So the contacts anyway, a switch basically what it does is it just bridges the contacts. I think it's called a 2-pole switch, I think. I'm rusty as anything with my physics, but anyway. Not a great deal to see. Bit of light on it if I could. So the metal contacts are basically connected up with the movement of the switch. That wire there, I think, makes contact when you flick the switch on. That wire then connects up these contacts, which completes the circuit. And then once the circuit's complete, everything's all working. It's all switched on, if you like. So when you flick the switch to the off position, I believe that wire, although I can't believe that wire is it, that must just be the light wire for the LED. There must be a heavier contact than that. But there is a contact. No, there we go, I found it. What a fright. So I found the contact. So that wire is for the light inside, because it looks too thin to carry heavy current. The current would just melt that wire. So that's just for the light, to light up the switch, the button. This is the contact, the physical movement. So when you, I don't know what way it goes in on this switch, but it fits in there somehow. It came flying out. But that makes contact with this metal switch, if you like, contactor there, you can see it at the end, makes contact with the corresponding bit there on the right. That completes the circuit. So the power is going from your plug through the switch when you switch it on, because when you switch this on, that contact makes contact with that contact, which completes the circuit. And there's I think that light's in parallel or something. I'm not 100% sure, don't quote me on it, but that is basically the switch that makes contact with the contacts in there. And then when it closes the circuit, it switches on the boiler. And when it's time to switch it off completely, so when you switch it off, it takes this contact off of the contact, which effectively breaks the circuit. It stops the power going to the rest of this circuit, because this is a circuit after all, because it's got to come from the line, from the plug, go around all this system, the appliance, and back through the neutral. Well, it's actually AC, it's alternating current, but I'm not going to all that. That's if it was direct. But basically, it's got to have an in, that's your live and neutral. So to complete a circuit in order to get it work, this is just basically breaking the circuit. Similar to that of a fuse. A fuse would use a very thin wire, and then when the power exceeds its maximum, it melts the wire, breaks the circuit. A fuse is in the plug, and there's one in your meter box. And in certain appliances, there could be an inline fuse as well, also in the appliance, to protect certain aspects of it. So what I'm going to do now is I'm going to get all this stuff put together in a sort of neat, orderly fashion, get a few photos, and round the video off. I was just thinking while I was getting this in some sort of presentable order, I was just thinking maybe breaking this lens off and having a look at the LED inside there to see what illuminates it. Shouldn't be too difficult, so I'll go and do that now. Right, so I've burst into the switch. There seems to be like I think I broke the bulb or glass that's in there. There is evidence of that. There is a wee resistor in there as well. If we could get that to focus, I could show you it. It's proving to be difficult. Hang on. There is a wee resistor in there. I could do a better job. I'll just flip the whole thing apart. Hang on. Right. So that would have been this was left of the LED. basically. That's, you even get to see inside of the LED now. I didn't plan on doing that, but you could get to see a wee bit inside an LED as well, because it broke in the process of getting the cover off. So there is that little resistor, and it did go to this glass, so you could see the kind of setup. That's what lights up the switch. And it's just a red lens basically that makes it look red, I think. I'm not sure if the LED actually produces a red light. But yeah, that's part of the switching mechanism. This is the actual contacts of the switch. That's the, it makes contact with the bottom bit there. This completes, where the wires go, it completes the circuit. So I'll get this in a bit of a tidy fashion. I'll get some photos and I'll just do a summary of the parts. So I've also decided to open up the plug to reveal the fuse inside it. So that's what would blow, that's your earth wire there. And the fuse, it's rated 13 amp because it's quite a heavy current, because it'll take a heavy current because it's a heating element and it's got a lot of water to heat. So I'll use, I don't know what the rating is, power specifications, there's somewhere I saw earlier. Where did I see them though? Ah, there we go. 1600 watts. Well, 1470 to 1600. So I've took all the still photos. Just the wee summary. That's the base ring, the bottom of the boiler, urn rather. This is the actual urn base cover, plastic, just plastic. That's the lid, it sits on the top. The one bolt, one Phillips screw that holds the handle on the lid. Then you've got two handles that go in the side of the urn tank itself. They're just held on with a Phillips screwdriver. A couple of washers, a locking washer, one at each side. Stainless steel tank itself, with the integrated element incorporated into the base of the tank. To me, I don't think this is a serviceable item. I think if this element goes, that's the whole thing knackered. You're going to have to buy a new one, I reckon. I don't see how that could come off. So if you've got one of them, just hope that that element doesn't go anytime soon, because you'll have to get a complete new urn. Switch setup, switch cover, LED for light, switch contacts for the terminals, spare connector's going to end. A multitude of fixtures, various screws, washers, lock nuts. That's your indicator lights, tell you whether it's on or off. Red one's for boil, green one's for keep warm. Some buttons, thermal cutout switches or thermal sensors or something. There's a button on the top that makes contact with this mechanism here. One's for the reset, that's the reset mechanism. That's the reboil mechanism, part of it. That's the other push rod that goes on this button. It goes on like such. Valve tap, went through that earlier. That's where the water comes out. It's wiring harness, that's the LEDs, which will be similar to what was used inside the switch, but these are for the lights, for the green and red light. That's the actual LED that lights up behind it. There's a close up of the LED, an unbroken one. So I broke one open accidentally when I was taking this switch apart, and you could actually see inside the LED to a degree anyway. It'll be similar to that. So that's the other one. I'm not sure what the green one is, or the red one. I'm not really quite sure, but that's the wiring harnesses. Is still another heat sensor or thermostat or thermal cut-off switch or whatever they're called. It's thermal something, and that white paste is thermal insulated paste. It's similar to what they use on heat sinks for amplifiers, microchips, when they go and they put the aluminium heat sink onto the amplifier chip to dissipate heat, and between the heatsink and the actual microchip they put conductive heat paste, sealing paste as well, so it conducts the heat. So that's on the base of these micro switches, thermal micro switch, and that's about it. Oh, the plug, I went through that, didn't I? And these are just brackets for the holding on the base. So that's about it. I can't really think of anything else to take apart regarding this boiler. Or I keep calling it a boiler. See, I'm not really used to these things. I've never had any dealings with them, so it really is. This is the first time I've took one apart in my life, to my knowledge. I've never had any dealings with these things at all. So it's all new to me, like. It's all new to me. Jeez, that's the time. I've got other things to get on with the day. I can't believe it took as long as it takes. It always takes longer than you plan. Didn't plan on it being as long as this, but it just somehow always escalates into being a lot longer. Anyway, that's the boiler, urn, kettle, whatever you call it. Urn. I'm not used to these things. I've never had many dealings, so it's alien. I don't have one in the house. I've never worked in a cafe, so the urn is taken apart completely now into its bits, down to its bare elements. Apart from the element itself, the heating element, which is incorporated in the base. So there you go, that's it. That's all I can do just now. I'm going to have to tidy all this up and get going. I didn't actually cut myself too badly on, even though I've got my gloves. When you wear rubber gloves, it kind of hinders the hand movements. You kind of get into the bits. You don't get the feel for what you're doing when you're wearing gloves. It's awkward, but that's just the way it goes. It's the price you pay. If you don't wear them, you get caught on sharp metal, then so be it. So, right, okay. So I hope you enjoyed the video. I've still got the clock to take apart. Got the electronic chessboard to take apart as well. And that will be that lot done. I'll probably look around for other things. I mean, that was just what my mate gave us there, but I'll be doing more than just these two. If I come across other things as well, then I'll take these apart as well and make a video of it. Well, anything like stuff like DVD player, old DVD player, old computer consoles, anything, just anything I could take apart. Within reason, anything that I could lift and put on this pacing table. You know, I mean, the cooker I took apart, but that was a bit bigger, but that's a pain in the arse. I didn't want to go to all that hassle again. But take a microwave apart, that was interesting. I've always been interested in that subject. So, right, that's it then. Okay, catch you later on. Just see what else put on my channel. Hope you enjoyed it. Bye for now. Just as a wee bonus before I go, I got one of these micro switches, thermal switches, and I just smashed it with a hammer. And this is what's inside one of them, just in case you didn't If you were wondering, I was wondering before I tied up. A couple of contacts. There must be like a conductive thermal. To be honest, I'm not 100% sure just how these things work, but so I just simply battered it with my hammer, and that was the best I could do for you. So that was just a little bonus for you and myself as well, because I wanted to see inside it too. Okay, thanks for watching.